In this video, we're going to cover the second part of 6-1, properties of exponents. Keep in mind, we need to remember to simplify, and there's no negative exponents or parentheses when we're finished. So some more properties of powers. So we have the power of a power. When we have a power to a power, such as a to the m to a to the n, we just multiply the two exponents. So a to the second times a to the third just becomes a to the sixth. Okay, then the power of a product is a times b to the m power. That exponent kind of just essentially gets distributed on to the exponent, or the bases. So it becomes a to the m times b to the m. The quotient is kind of the same thing. A over b to the n power, that exponent again just gets distributed to both. It becomes a to the n over b to the n. And then if it's a negative, it can just flip the whole fraction. And then the power of 0, this is one of the best properties of exponents. Anything to the 0 power is equal to 1 except 0. So it's always one of the nice. Anytime you see something to the 0 power, you're done. The answer is 1. All right, so let's look at some. So we have a to the third to the 6th power. So when it's a to the third to the 6th power, it's a power to a power. You just end up multiplying the two numbers. So we get a, and then multiply those two numbers, we get 18. So a to the 18th power. And that's all there is. That's as simple as it is. So now, the next one, we have negative 3 times x over y to the 4th. So that 4 gets distributed onto everything on the inside. So we get negative 3 to the 4th, x to the 4th, over y to the 4th. Well, we can simplify that negative 3 to the 4th. That negative 3 to the 4th, that is 81. And then the rest, there's nothing to do. So we have x to the 4th over y to the 4th. And that's it. Again, no parentheses, no negative exponents. So here, negative 2, p to the 3rd, s to the 2nd, to the 5th. So again, that gets distributed onto everything. And then negative 2, so negative 2 to the 5th, p to the 3rd to the 5th, and s squared to the 5th. Now look at all these parentheses we got. We got to get rid of them. So negative 2 to the 5th power, that would be negative 32. Next one, p to the 3rd, this is a power to a power, so we get p to the 15th. And then the last one, another power to a power, we get s to the 10th. And that's all there is to it. The next one, a over 4 to the negative 3. So right away, that negative exponents, I can take everything on the fraction on the inside of the parentheses, and I can flip them. So I can flip it right away to 4 over a and drop the negative exponent. So then that exponent gets distributed. So I get 4 to the 3rd over a to the 3rd. Well, 4 to the 3rd, that's just 64. And then a to the 3rd is nothing I can do, so I'm done. All right. So now this is just a little bit, this is everything we've learned. Okay. So we can start on the inside or we can start on the outside. So we have negative 2x to the 3n over x to the 2n, y to the 3rd. So once again, we can distribute right away. Distribute. Now the 3n is the exponent itself. So we get negative 2 to the 4th, and then x to the 3n raised to the 4th over x to the 2n to the 4th times y to the 3rd to the 4th. So all of these are power to power. Well, negative 2 to the 4th, that one's pretty simple. That's just 16. Not a negative 16, it's just a positive 16. X to the 3rd, so now think of that. It's just 3n times 4. Well, that leaves us with x to the, a little big on that one, x to the 12n. And then from there, we just keep moving on. We distribute here, so we have x to the 8n, because we're just multiplying. And then the last one, We just distribute, it's power to a power, so we get y to the 12th. So now we notice, wait a minute, we have the base is the same. We can combine these two. What's 12n minus 8n? Well, 12n minus 8n is just 4n. So we have x to the 4n. We didn't do anything else with any of the others. Y to the 12 stays the same, and 16 stays the same. So we're left with 16 x to the 4n over 12, or y to the 12th. And there we go. Okay, keep going. So now, last thing we're talking about, scientific notation. We have a times 10 to the n, where n is just an integer, just some positive or negative integer, so a whole number, positive or negative, and a lies between 1 and 10. Any number, decimal, that lies between 1 and 10. It can be 1, but it cannot be 10. All right? So, now the rules apply with scientific notation that we've just been working on. So, after the sun, the next closest star is Alpha Centauri C, which is about 4 times 10 to the 16th meter. How long does it take light from Alpha Centauri C to reach Earth? Use the information at the left. So it says light travels at a speed of about 3.00 times 10 to the 8th meters per second. The distance that light travels in here is called light years. So now we want to find how far. So what we have to do is, in this case, we got to find the distance that light travels. So we need to divide them out. Okay? So we got to figure out time. So we have 4 times 10 to the 16th over 3 times 10 to the 8th. And again, it's the same thing. Combine the like parts. 4 over 3. That's approximately 1.33. So our first number is between 1 and 10. The times is just the times. It's not an x. It's a time symbol. And then 10 to the 16th over 10 to the 8th. They're the same base, so we just subtract. So we get 10 to the 8th. So it takes approximately 1.33 times 10 to the 8th seconds. That's how long it takes for light to reach Earth from Alpha Centauri.